Hello everyone, so today we're going to do the assignment chemical bonding. So in this video I'll just basically ramble on and just go question by question by question by question. So you may want to go and you will probably have the answer key with you already, and you will just go to the different timestamps for the different questions so that you can find targeted help for which question you still do not understand. Okay, so let's begin. So for the first part, annotating the periodic table. So for the periodic table, I start with my hydrogen, staircase from boron, going down, metals on this side, non-metals on this side, +1, +2, +3, plus and -4, -3, -2, -1, and 0 or X. Okay, and then this is period 1 next to lithium, period 2 next to neon, period 3 argon, period 4 krypton, period 5 xenon. Okay, so now we are at ionic bonding question number 1. So ionic bonding question number 1, what change is required to convert a sodium atom 2.8.1 into a sodium ion? So we know that sodium atom is a metal, so metal will lose electrons. So it will lose how many electrons? It will lose 1 valence electrons to become 2.8. So no protons, no adding, but lose is removed, so lose 1 electron. Answer is D. Right, now for question number 2. Question number 2, the proton number of an element X is 19. So X forms an ionic compound and it will form an ion. I see. So I need to write the electronic configuration first. So for 19, it will be 2.8, that's 10, 8, that's 18, and then 1, that's 19 electrons. So the electronic configuration of the ion means I will have to lose this one away, lose. So that will leave 2.8.8 for the ion. So the answer would be A. Alright, just remember that ion will always have a full valence shell. Okay, good. That was question number 2. Question number 3. What does this diagram show? So the diagram show I can see that there's 11 protons, I can see that there's 12 neutrons, I can see that there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I can see that there is 10 electrons. So first thing that I notice is that the number of P is not equal to the number of E. So when the number of P is not equal to the number of E, it is an ion. If P is equal to E, then it is an atom. So firstly, this one is an ion, so it cannot be D. So it's ion. Now I know that there is 11P, so there's 11 plus, and then there's 10E, that is 10 minus. So 11P, 10 plus, 10E, 10 minus. So that means there's more plus than minuses. So overall is a plus, a 1 plus. So therefore the answer is B. Question number 4. Draw the dot and cross diagram to show the structures of the following substances. So now you need to refer to your periodic table very often. So first one, magnesium, group 2, oxide, group 16 for oxygen. And I know these are all ionic, so this is metal and this non-metal. So I'm looking for my square brackets. So magnesium is Mg from group 2. Oxygen is O from group 16. Straight away, don't care, just draw 8 electrons. Group 2 on top should say 2 plus. Oxygen group 16 should say 2 minus. And 2 minus means 2 crosses from the Mg. Then I fill up to make sure until I have 8. Let's check. 1, 2, 3, 4, 5, 6, 7, 8. Alright. Now I have 2 plus and I have 2 minus, so 2 plus will cancel 2 minus, so I only have 1 Mg 2 plus and I have 1 O 2 minus. So therefore the formula is Mg1O1. Okay? Or MgO. Next, potassium oxide. So potassium is a metal Oxide is a non-metal. Potassium is from group 1. Oxide is from group 16. So I know it's a metal and non-metal. So let's write potassium. Confirm will have 8. So let's just cross it all. And then group 1 is 1 plus. And then oxide O, square bracket. Group 16, on top you check the periodic table, it should say 2 minus. So 2 minus means that there is 2 crosses. And then the rest will be filled up with the other symbol. Okay, so now I got 1 plus and I got 2 minus. So I have a 1 plus. I have a 2 minus. So that means I need another 1 plus. So that means I have 2 K plus and I have 1 O2 minus. So therefore I have 2 K plus and 1 O2 minus. So that is K2. The 2 become here. The O, there's a 1. So K2, O1. 2K and 1O, or K2O. Right, next we got lithium. Lithium is from group 1. Bromide is from group 17. And I remember that lithium is a special case. What do I mean by a special case? Lithium is special case because it's in period 1, so a full shell is only just 2 electrons and not 8. Draw square bracket. Group 1 is 1 plus. Then bromide is Br. Circle. Right, square bracket. Check my periodic table. Group 17 on top is 1 minus. 1 minus means that there will be 1 cross. And then the rest to fill up until it becomes 8. Li 1 plus, Br 1 minus, balance. So there's 1 Li, 1 Br. So Li 1, Br 1, 1 each, or Li Br. Okay, last question from Ionic. So calcium fluoride. Calcium is from group 2, check your periodic table. Fluoride is from group 17, check your periodic table. So Ca, circle, draw 8 already. 8, square bracket. Group 2, look at on top, 2 becomes 2 plus. Fluoride. Group 17 is 1 minus, check the top. 1 minus means there is 1 cross, and then the rest would be circles. Now, there is a 2 plus, and there's a 1 minus. So that means I need another 1 minus to make it balance. So that means I need to draw another F. Oh, I realized I made a mistake. Let's go and check it out. Oh, let's go and check it out. This is the only place I have space. I need to draw another K plus here, right? Yes, I need to draw another K plus. 1, 2, 3, 4, 5, 6, 7, 8. Another K plus here. Oops. Okay. Now, over here, I have 1 Ca2 plus and I have 2 F minuses. So therefore, this is Ca1 F2 or CaF2. Alright. So that's for ionic. Let's move on to covalent bonding. So which pair of elements is most likely to form a covalent compound? So let's just quickly revise covalent bonding. Covalent bonding is non-metal plus non-metal, and non-metal will form covalent, and covalent will form molecules. So that's what we need to remember. So we're looking for pair of elements, we're looking for 2 non-metals. Chlorine, non-metal, sulfur, non-metal. Magnesium, metal, sulfur, non-metal. Potassium, metal, sodium, metal, iron, metal, oxygen, non-metal. So answer is A. Which of the following, question number 6. Which of the following best describes how a covalent bond is formed? So covalent bond must be sharing. So transferred, no. Shared, yes. Gain, no. Shared, yes. But the D shared is actually a proton, so definitely wrong. So it's a sharing of electrons, so B. Alright, now dot and cross of covalent substance is the one that looks like this. So overlapping circles, right? Different from the ionic. So chlorine is ClCl. You must remember that ClCl, if you look on top of the periodic table, is 1 minus, right? So that means it can form 1 bond. So structural formula will look like this, ClCl. So the dot and cross diagram will look something like that. ClCl, draw your overlapping circles. Single bond has how many electrons? It has 2. let me just erase it to make it neater. So 2 electrons, cover one Cl, and it needs 6 more electrons because that makes a total of 8. Cover the other Cl, another 6 more electrons. Next, H2O. H2O means there's 2 H and 1 O. H has 1 bond. O belongs to group 16. So you see it's 2 minus. 2 minus means that there's 2 bonds. So 2 bonds. So it will look something like this, right? And then I'll draw this and do my overlapping circles. They are all single bonds. So single bonds got 2 electrons each. Okay, the 2 H are happy, they have 2 valence electrons, but the O is not. So O currently has 4 electrons only. So I'll fill up with another 4. So now the O has a total of 1, 2, 3, 4, 5, 6, 7, 8 electrons. Next, hydrogen. Hydrogen H2. So that means it's H, H. Hydrogen got 1 bond each. So it's H, H. So it's a single bond. Let me just erase the line just to make it neater. So single bond got 2 electrons and my hydrogen is happy. 2 electrons each. Oxygen, O, O. Oxygen group 16, 2 minus. So 2 minus means that there's 2 bonds. So therefore the O form a double bond with the other O. So O form a double bond with the other O, overlapping circles. And then a double bond has a total of 2 times 2, so 4 electrons. So I'm going to draw 4 electrons inside here. 1, 2, 3, 4. So one O has 4 electrons, so it needs another 4 more. The other O also has 4 electrons, so it needs another 4 more. Right, next. Hydrogen chloride, HCl. We got 1 H and got 1 Cl. Hydrogen got 1 bond. Cl is from group 17. If you look on top of the periodic table, it's 1 minus. So that means it has 1 bond. So the structure will look like this. 1 bond from the H form 1 bond to the Cl. So 1 bond to the H to form 1 bond to the Cl. Draw overlapping circles. Single bond is 2 electrons. Erase it off. 2 electrons. Now the H is happy. The chlorine needs to have 6 more. Then you have 8 around it. Ammonia, NH3 means N and 3 H's. H again, got 1 bond each. I hope you get used to H getting 1 bond each. Nitrogen is from group 15. If you look at group 15, on top is 3 minus. 3 minus means that there's 3 bonds. Okay, so therefore you look, nitrogen will form 3 bonds, and then it will form H, H, and then H. So they are all single bonds. So single bond got 2 electrons. We draw the overlapping circles. I think I would not erase the line. Let's try. Erase this line, erase this line, erase this line. Single bond got 2 electrons. All the hydrogens are definitely happy. So I just, nitrogen got 1, 2, 3, 4, 5, 6. So I draw 2 more. Ammonia. Methane. Methane CH4 means got 1 C and 4 H's. H got 1 bond each as per normal. C is from group 14, so it's 4 plus 4 minus, so that means there is 4 bonds over here. So C in the middle, 4 bonds, bond with 4 H's over here. Right, so overlapping circles, overlapping circles, overlapping circles, and then over here, single bond each, my carbon also happy. Carbon dioxide CO2, so COO, carbon group 14, so 4 bonds, O, 2 bonds each, 2 bonds each. So I need to have double bond to a O, double bond to a O. So C double bond O, C double bond O. Overlapping circle. Double bond has a total of how many electrons? 4 electrons. So double bond has 4 electrons. 1, 2, 3, 4. 1, 2, 3, 4. So the carbon is happy, it has 8 electrons. The oxygen only has 4, so I'm going to draw another 4 more. The other oxygen also only has 4, so I'll draw another 4 more. Okay, good, we are done with down and cross. Now we're in the third section, so properties of ionic and covalent substances. So you must remember that the melting point and the conductivity of ionic is very special. So I think that's the first question. So question number 8. Which row shows the general property of an ionic compound? So when I look at an ionic compound, I will most likely look at the electrical conductivity first. So when I look at electrical, solid cannot, but aqueous and liquid can. So I'm looking for that one. So solid cannot, liquid can. Okay, liquid can. So it's either one of this, and then, melting point high, that's correct. And then ionic must be soluble in water. So the answer here is B. Covalent substance, melting point is always low. Boiling point is definitely not high. And it cannot conduct electricity at all. So because there's no mobile ions. Okay, poor. So D. Now, ionic compound, easily molded into different shapes means that it's soft? No. Can conduct electricity when it's solid? No. High melting points? Yes. They never dissolve in water? No. So answer is C. Which statement of ionic compound is correct? They are formed by sharing, so this is wrong. It is by a transfer. They conduct electricity as they have free moving electrons. Answer is wrong because it's not electrons, it is ions. They do not dissolve in water. That is wrong. They have high melting points due to the strong attraction between ions. Good. So this is D. Substance X has the physical properties listed. So it's low melting point. So it makes me feel like it's covalent. Non-conductor, covalent. Insoluble, covalent. So therefore this is B. Now, I have the arrangement of sodium and chloride ions in the crystal of sodium hydroxide. This is my crystal lattice, right? Why have high melting point? So high melting point means that the forces of attraction is strong. So let's start the explanation. So forces of attraction, right? So forces of attraction is what? Strong, right? So but it's between ionic, so force of attraction between ions is strong. And so what if it's strong? A lot of energy required to overcome forces. So therefore melting point is high. Keyword, force of attraction, ions, strong. Energy, a lot, overcome. Cannot use the word break, remember. Next, explain why sodium chloride has to be dissolved in water for it to conduct electricity. So you must say that in solution and liquid, mobile ions present. So this is half of the explanation. You must tell me in solid. In solid, ions in fixed position, no mobile ions present. So the keywords that I need to see here is ions in fixed position, mobile ions, no mobile ions. Finally, explain why gaseous hydrogen chloride, H, chloride Cl, non-metal, has a low melting point. So low melting point means that the forces of attraction, right, is weak. Okay, so the force of attraction is weak. Now we need to decide what is this force of attraction in between. So because this is covalent, so non-metal, covalent form molecules. So force of attraction between molecules. So we need to get this part right. Right? So force of attraction is weak firstly, and then must be between molecules. Ionic is between ions. So when it's weak, then you must say that little energy required to overcome the forces. So again, key, little energy, overcome. Okay, so I hope this has helped you understand and practice to answer some of your questions. Thank you. See you next one. Bye bye.